Good morning to all. In today's class, we will discuss typecasting in Java. Already you know typecasting in C language. Now we will discuss typecasting in Java language. Okay, it is completely different from C language. We will see the typecasting in Java language. Okay. Now here if you see typecasting, okay, there are two types. Okay, there are two types in typecasting in Java. What are the two types? Primitive typecasting and non-primitive typecasting. Okay, so we will see what is the difference between primitive typecasting and non-primitive typecasting. Okay, already you know primitive data types in Java language now. So how many primitive data types are there in Java language? There are only 8 primitive data types in Java language. They are byte, short, int, long, char, boolean, float, double. These are the only 8 primitive data types which are there in Java language. Okay, so if you do the typecasting with respect to any one of these 8 primitive data types, then that typecasting is called primitive typecasting. Okay, and now here I have written casting is done with primitive data type. Then that type of casting is nothing but primitive typecasting. Okay, so primitive typecasting is there in C language also. But in C language, we have only primitive data types. There is no concept of non-primitive data type in C language, because C is not object-oriented programming language. In C language, we don't have the concepts classes and interfaces. Only in object-oriented programming languages, we have the concepts like classes and interfaces. That's why in C language, we don't have the concept non-primitive typecasting. So in C language, only we have primitive typecasting. So that is the difference between typecasting in C language and in Java language. In C language, we have only primitive typecasting. But in Java language, we have both primitive typecasting and non-primitive typecasting. These two concepts are there in Java language. But only this concept is there in C language. Okay, that is the difference between C language and Java language with respect to typecasting. Okay. Next, we will see what is non-primitive typecasting. Because Java is an object-oriented programming language, that's why in Java we have the concepts classes and interfaces. Using classes and interfaces, we will write the programs in Java language. Okay. Now here, a non-primitive typecasting means, you know already in data types, we have non-primitive data types. So in data types concept, we have two types of data types in Java language. They are primitive data types and non-primitive data types. Primitive data types means only 8. But coming to non-primitive data types, with respect to classes and interfaces, we can explain the concept non-primitive data type. That's why, so in non-primitive typecasting, we use classes and interfaces. So what is the meaning of this is, if the casting is done or if the typecasting is done with non-primitive data types, that is either with classes or interfaces, then that type of typecasting is called non-primitive typecasting. See here, if you take data types, there are two types of data types in Java language. They are primitive data types, non-primitive data types. Next, coming to variables, there are two types of variables in Java language. They are primitive variables and non-primitive variables or reference variables. Next, if you take typecasting concept also, again there are two types. They are primitive typecasting and non-primitive typecasting. Because in any object-oriented programming language, we have to discuss non-primitive type also in addition to primitive type. Already in C language, we know only primitive type. But if you take any object-oriented programming language, whether it is R or Python or Java, we have the concept of non-primitive type. So that's why if you take data type, we have non-primitive data type. If you take variable concept, we have non-primitive variable or reference variable. If you take typecasting, we have non-primitive typecasting. That's why try to understand the concept of object-oriented programming language. In any object-oriented programming language, we have the concepts of classes and interfaces. Okay, these two come under non-primitive type. That's why if you take data type or variable or typecasting, we need to explain both the concepts, that is primitive and non-primitive. Okay, so non-primitive concept is only available in object-oriented programming languages, but primitive is available in both object-oriented programming languages or structured oriented programming languages like C, Fortran and Pascal. Okay, now whenever you discuss about object oriented programming languages, this part is very, very important. That is non-primitive type. Okay, so here primitive typecasting and non-primitive typecasting. Now you can understand the difference between primitive typecasting and non-primitive typecasting. If the typecasting is done with any one of the 8 primitive data types, then that typecasting is called primitive typecasting. If the typecasting is done with any non-primitive data type, that is either with class or with interface, then that type of typecasting is called non-primitive typecasting. So that is the difference between primitive typecasting and non-primitive typecasting. After that, coming to the primitive typecasting, again here we have 2 types. So in primitive typecasting, we have 2 types. They are implicit typecasting and explicit typecasting. See, already I explained, primitive typecasting is there in C language also. That's why the primitive typecasting already we studied in C language. So here also same, because C is a subset of Java. All the concepts which are there in C language, they are also there in Java language. But in addition to those concepts which are there in C language, we will study extra concepts like non-primitive typecasting or non-primitive variables, non-primitive data types. This is added to Java language. It is not there in C language. But primitive typecasting is there in C language. Already we know implicit typecasting and explicit typecasting, same concepts which are also there in Java language. Okay, anyway, I will explain these 2 typecasting, these 2 types also now with example program. After that, concentrate more on non-primitive typecasting. This is very, very important in Java language. Okay, now we will complete first primitive typecasting. So here again there are 2 types now, implicit typecasting and explicit typecasting. Now what is the difference between these 2 types is, implicit typecasting is nothing but if the lower data type is assigned to higher data type. Okay, then that is called implicit typecasting. So why it is called implicit typecasting is, it is done automatically by the compiler. You need not worry about implicit typecasting. It is internally done by the compiler. When we say it is implicit typecasting is when the lower data type is assigned to higher data type. I will show with, or I will explain with example both these concepts. Now try to understand what is implicit typecasting is. If the lower data type is assigned to the higher data type and it is automatically done by the compiler. Next, explicit typecasting means the programmer has to do explicitly. Okay. Now here what is explicit typecasting? If the higher data type is assigned to the lower data type. Okay. Now I will explain these 2 concepts. That is primitive typecasting with example program. Okay. First understand what is primitive typecasting. Okay. And what are the types of primitive typecasting. Next, coming to the non-primitive typecasting. So with respect to classes and interfaces, we will see non-primitive typecasting. And non-primitive typecasting is explained with respect to inheritance only. Okay, without inheritance, there is no concept of non-primitive typecasting. Already I completed inheritance. Okay, you know what is inheritance and what is the advantage of inheritance and what are the different types of inheritance, and we have written programs using inheritance, and in inheritance we have studied method overriding concept, and I also explained super and final keywords with respect to inheritance in the last class. So all these are related to inheritance. We have covered inheritance. Okay. Now in inheritance, what is the next concept is non-primitive typecasting. Okay. This concept is available only in inheritance. Without inheritance, we can't explain the concept of non-primitive typecasting. But to explain the concept of primitive typecasting, no need of inheritance. Means with one class only we can explain primitive typecasting. Already explained. For inheritance we need two classes, one superclass and one subclass. Always subclass extends superclass. Means subclass is having the properties of both superclass and subclass. That is the advantage of subclass. Okay, you know inheritance. Single level inheritance, multi-level inheritance, and hybrid, not hybrid inheritance, hierarchical inheritance. We have three types of inheritance. That is single level inheritance, multi-level inheritance, and hierarchical inheritance. Already I explained these three types with example programs. Okay. Now you know inheritance in depth. Now with respect to inheritance, that is with respect to two classes. That is superclass and subclass. I will explain the concept of non-primitive typecasting. But for primitive typecasting, okay, only one class is enough. Okay, we need only one class. Means inheritance is not required in case of primitive typecasting. With one class, I will explain implicit typecasting and explicit typecasting. But if you take non-primitive typecasting, compulsory two classes are required. Okay, they are superclass and subclass. Means inheritance is required to explain the concept of non-primitive typecasting. Okay. So next, so in non-primitive typecasting, again here we have two types. They are upcasting and downcasting. What is upcasting? So with respect to superclass and subclass, I am explaining the concept non-primitive typecasting. So under this we have upcasting and downcasting. So what is upcasting? If casting is done with respect to the superclass, then it is called upcasting. See here you can understand up means it is nothing but superclass. So if casting is done with respect to superclass, then it is called upcasting. Next, what is downcasting? If the casting is done with respect to the subclass, then it is called downcasting. So down means subclass. You remember like this. Down means with subclass we are doing typecasting. Up means with superclass we are doing casting. So that's why in non-primitive typecasting, inheritance is required. In inheritance we have superclass and subclass. If the casting is done with respect to superclass, then that is called upcasting. If casting is done with subclass, then that casting is called downcasting. So this is about typecasting in Java. So here we have two types of typecasting, that is primitive typecasting and non-primitive typecasting. So primitive typecasting is done with respect to primitive data types, and non-primitive typecasting is done with respect to classes and interfaces. And inheritance is required for non-primitive typecasting, and inheritance is not required for primitive typecasting. Okay, this is the gist of typecasting in Java. Now we will see. So if you see this typecasting in Java, totally we have four different types in typecasting in Java. What are the four? Implicit typecasting, explicit typecasting, then upcasting and downcasting. But in C language we have only two types. They are implicit typecasting and explicit typecasting. Okay, in C language only two types, implicit and explicit. But in Java language, because Java is an object-oriented programming language, so we will take classes and interfaces in Java language. That's why with respect to classes and interfaces, we will see non-primitive typecasting. This is the extra one in Java language. It is not there in C language. Okay, so in Java language, we have four different types of typecasting techniques. They are implicit typecasting, explicit typecasting, upcasting, and downcasting. Now we will complete or we will see the programs for each of these four concepts. Implicit typecasting, explicit typecasting, upcasting, and downcasting. So these two are explained with respect to primitive data types, and these two are explained with respect to classes and interfaces, and with respect to inheritance. Okay, now we will see the programs on each type. So here I have written inheritance is not required in case of primitive typecasting, but it is required in case of non-primitive typecasting. You know inheritance very well. Now I will explain the program. Okay. Now write a Java program using primitive typecasting. So you know in primitive typecasting we have two types. They are implicit typecasting and explicit typecasting. Now I will write these two types in a single program. Okay, inside one class I can explain the two types of primitive typecasting. They are implicit typecasting and explicit typecasting. This is there in C language also, but the way of writing the program is different. In C language directly we will start hash include stdio.h, hash include conio.h, and directly we will take void main norg. Now to write C program. This part is same, but only difference is printf statement and scanf statements we will use in C language. Here in place of printf statement in C language, here we use system.out.println. Okay, only few differences. Otherwise, logic part is same if you take C language or Java language. Only the way of writing the program is different. Okay, how do we write Java programs? So to write the Java program, compulsory class is must. Without class, we can't write Java programs. Please remember this point. Okay, without class, we can't write Java program. So that's why we need to take class first. So here already explained in primitive typecasting class, this inheritance is not required. That's why I will take only one class. Inside that class, I will explain both implicit typecasting and explicit typecasting. In the same program, I will explain. This is a single program, and in this program, I have taken only one class. Means inheritance is not there. Okay, shall we start this program? Now how do we write Java program? Class test. This is class is a keyword, and this is the class name, which is an identifier, and the naming convention for class is the first word, first letter must be capital letter. We should follow the naming conventions for classes, interfaces, packages. Okay, compulsory we need to follow, because some people followed the naming conventions when they write the programs on classes, interfaces, and packages. So the same naming conventions we should follow. So you know the naming convention for class. So the naming, what is the naming convention? So if it is the class name is a single word, means the first letter of that word must be capital letter. If it consists of more than one word, then the subsequent words first letter must also be capital letter. Okay, the first word, first letter must be capital letter, and the subsequent words, first letters must also be capital letters. So that is the naming convention for class. So here class is a keyword, class name is an identifier, and here we have followed the naming convention for class while writing the class name. Okay, you need to explain like this, each and every point is important. Okay, after that, this is the class definition. This is the opening brace of class, and this is the closing brace of class. So inside that class, we should write main method. Always JVM will invoke the main method first. Always the execution of any program starts from the main method only. That's why inside this class, first write the main method, Inside that main method, write the logic of that program. Okay, like that you can write the Java program. So what is the main method syntax? I will explain this entire statement later after completion of the static keyword. Now try to understand, this is for command line arguments. I will explain next static keyword and command line arguments. At that time I will explain this total statement. Why we should write this entire statement. This is must. Okay, what is the statement? Public static void main, okay, parenthesis string args. Okay, I will explain this later. This is the main method syntax. So this is the main method definition. Definition means this is the opening brace of main and this is the closing brace of main. So inside the class test we have written main method. That's it. Okay. Now I will explain implicit typecasting. So what is implicit typecasting? Already you know. Okay. If the lower data type is assigned to higher data type, then it is called implicit typecasting. So byte b is equal to 10. First I will declare a variable b with byte data type and the value assigned to b is 10. Okay, after that what I will do is, see here it is wrong, int a is equal to b. I am taking one more variable a and that is assigned with b, because b is already assigned with 10 now. I am assigning b value to the variable a which is of int data type. If you see, or here I will explain, here it is correct. Here it is only change the variables a, interchange these two variables a and b. Okay, int a is equal to b, correct. Same thing here I have written, int a is equal to b. Means what is the data type of b? Data type of b is byte. So this is byte data type. And what is the data type of a? Int data type. You know, in primitive data types, byte, short, int, long. You know the bytes 1, 2, 4, 8. Means byte takes 1 byte, int takes 4 bytes. So b is a variable which is declared with byte data type. That's why it is taking 1 byte of memory. But if you take int a, the variable a, it is taking 4 bytes of memory. Means 1 byte of memory can be, the value which is stored in 1 byte of memory can easily be assigned to a variable with 4 bytes of memory. You can understand easily. Means lower data type is assigned to higher data type. Byte is, b is declared with byte data type which is taking 1 byte and a is declared with int data type which is taking 4 bytes. Means 1 byte of memory. The value which is stored inside 1 byte of memory can easily be stored inside 4 bytes of memory. This type of typecasting is nothing but implicit typecasting, and this is done by the compiler. Means if you write int a is equal to b, then compiler will automatically add this typecasting. Means you know parenthesis is cast operator. Whatever data type is there which is there on the left hand side, always typecasting is done with respect to the left hand side data type. Okay. Now what is the left hand side data type? Int. That's why here the typecasting is done with int data type, and it is provided by the compiler during the compilation time. We will write only int a is equal to b. Then what will happen? Internally the compiler will add this typecasting, that is casting with int, to this statement. You need not write explicitly. If you write explicitly also correct, no problem. Otherwise also compiler will add this typecasting during the compilation time. Okay, this is nothing but implicit typecasting. So after that, so here b is holding 10 and a is and b is assigned to a. No, b is assigned to a, means a is also having 10. If you print system.out.println, you will get 10 plus 10, 20. Okay. Next we will see, or we can print the values independently, that is a value and b value. Here it is concatenation operator plus. Here both are integers. No? If both are integers, then plus will add as addition operator. That's why 10 plus 10 is 20. If you see this one, you will get the output 10 space 20. Because it is plus is called concatenation operator here. One is string and one is integer, means the total is string. Again the string, that string is added to this 20 Again totally you will get a string. That is what 10 space 20. You understand the difference between these two statements. Here plus is acted as addition operator because it is adding two integers, but here plus is acting as concatenation operator because it is adding a string and an integer. String and integer is an integer. Okay, understand the difference. Next, after that, explicit typecasting. So what is explicit typecasting? Explicit typecasting must be done by the programmer only. Implicit typecasting is done by the compiler. You need not worry about this typecasting here. The compiler will add. Okay. But in explicit typecasting, we need to do explicitly. Now I will explain with one example. What is explicit typecasting? If the higher data type is assigned to the lower data type, then that is called explicit typecasting. Means opposite to this. Here byte is assigned to int. Means lower data type is assigned to higher data type. But opposite to that one is, okay, higher data type is assigned to lower data type. So here if you take first int a is equal to 100. Okay, next after that what I am doing? Byte b is equal to a. So a is declared with int data type which is taking 4 bytes of memory, and b is a variable which is declared with byte data type which is taking 1 byte of memory. Here I am trying to assign 4 bytes of memory into 1 byte of memory. Means it is not possible. That's why if you write like this, you will get compiler error. So how to overcome this compiler error is by doing the explicit typecasting. Already explained, typecasting is always done with the left hand side data type, whatever it is. So here in this statement, what is the left hand side data type? Byte. That's why to avoid the compiler error, what I will do is I will write the same statement with this explicit typecasting. So byte b is equal to, okay, cast operator inside that byte, this is a. Means we are doing here explicit typecasting. In this case, no compiler error. Now here you may get one doubt. Int a range of int is very large, but range of byte is -128 to +128. So if you take a value which is outside the range of byte, okay, a is declared with integer, no? So we can take any value within the range of int, no? So I will take a value which is outside the range of int. Then after typecasting, even though we are not getting compiler error, but the exact value is not stored inside the variable b. Why? Because the value, this value which is there within the range of int is not fitted into this 1 byte of memory. That's why we won't get compiler error, but you won't get the exact value for this byte. When you will get the exact value is if you take the value a which is within the range of byte, then that is copied into b. But if you take the value for a which is outside the range of byte and within the range of int, then it is not copied exactly into the variable b, but you won't get exact value, but you will get some value, but you won't get compiler error. So this is nothing but explicit typecasting. So after that, print the values of a and b. You in the lab session, you do this one. You give the value for a two ways. One is take within the range of byte, then see the value of b, and next take the value within the range of int but outside the range of byte. Then again see the value of b. Okay. So here I am printing the values of a and b. Okay. So you know press is concatenation operator. If at least one string is there for this concatenation operator, the output is a string. Okay, so this is a program on, okay, primitive typecasting. So here in this program I have explained both implicit typecasting and explicit typecasting. And here if you observe, I have taken only one class. That's why inheritance is not required for primitive typecasting. Okay, so with this primitive typecasting is completed. Next we will start non-primitive typecasting. So what is non-primitive typecasting? If the typecasting is done with respect to any one of the non-primitive type, that is either class or interface, then that casting is called non-primitive typecasting. Here under non-primitive typecasting, here we have two types, upcasting and downcasting. First we will see a program on upcasting, then we will see a program on downcasting. Okay. Now what is upcasting? Okay, already explained. We have to explain this concept with respect to inheritance only. Okay, so with inheritance we can explain both upcasting and downcasting. So inheritance means we will take both superclass and subclass. Two classes are must in inheritance. One is superclass and another one is subclass. So with respect to superclass and subclass, I will explain upcasting and downcasting. So what is upcasting is, if the casting is done with superclass, then that casting is called upcasting. Okay. So this is the inheritance. Here I have two classes, A is superclass and B is subclass. So with respect to these two classes, first I will explain upcasting, after that I will explain downcasting. Okay. Next, what is upcasting? First understand the concept of upcasting with respect to these two classes, that is superclass and subclass. So what is upcasting is, if subclass object is assigned to superclass reference variable, then that casting is called upcasting. So with that reference variable, what we can access is, we can access all the members of the superclass except overridden method. Already in inheritance, I explained the concept of overriding. If both superclass and subclass are having the same method with the same prototype, then the method in the superclass is called overridden method and the method in the subclass is called overriding method. Okay. So here what is there here? Okay. So first again I will explain this one. Understand, if you understand these 2 points, writing the program is 1 minute. So what is upcasting? Subclass object. You know how do we create subclass object? B1 is equal to new B, that's it. Means right hand side is called object. That is new B is called object. Already explained this one. Whenever you create an object, only the right hand side part is called object. That is new B, parenthesis, that is called object. And B1 is equal to new B, means right hand side is object for B class, and B1, no, that B1 is called reference variable. Okay. Okay, B1 is equal to new B, means in that syntax, B is called reference variable and right hand side that entire part is called object for B's class. That is new B is object for B's class. So here what I am doing is, if subclass object is assigned to superclass reference variable, subclass object means right hand side part only, is assigned to superclass reference variable. How do we create superclass reference variable? A1. A1 is nothing but this A1 is called a reference variable of superclass. And what is subclass object right hand side? New B. Now what is the syntax for this is, A1 is equal to new B parenthesis. Means subclass object is assigned to superclass reference variable. Then this type of casting is called upcasting. Next, with that reference variable, means A1 is equal to new B, no? With that reference variable A1, what we can access is, we can access all the members of the superclass except overridden method of the superclass. Okay, I will explain this program. Now, inheritance is must, no? So here I have taken one superclass and one subclass. Superclass is animal and subclass is dog. Dog extends animal. Here in this, what are the properties of animal? A, B, and methods of animal class, eat and sleep methods. If you take dog class, the properties of dog class A, C, and methods are eat and bark. So this eat is there in both the classes. This eat method is called overridden method and this eat method is called overriding method. Understand, if a method is there in both superclass and subclass, superclass method is called overridden method, subclass method is called overriding method. Already explained in overriding concept. Okay. Now I will explain upcasting. We will concentrate. You know inheritance, no? Now I am assigning the values to A and B. Next eat method, this is animals eat method. Next sleep method, animal sleep method. That's it. So animal class consists of two instance variables A and B, and which are initialized with 10 and 20, and two methods eat and sleep. Okay. So inside that I have written animal sleep method and animal sleep method. That's it. Next I will take one subclass which extends animal, that is class dog extends animal. Inside class I have taken two variables A and C. Already explained the instance variable hiding. If both superclass and subclass are having the same variable name, then it is called instance variable hiding. Means subclass variable will hide the superclass variable. Already explained the concepts of instance variable hiding and method overriding. Okay. Now class dog extends animal. Here we have two variables A and C and two methods, that is eat and bark. So here it is dogs eat method. Next it is dogs bark method. But here if you observe, eat method is there in both superclass and subclass. In superclass eat method I have written it is animals eat method. In subclass eat method I have written it is dogs eat method. Okay. Now we have two classes, animal and dog. Understand this structure. Animal class is having two variables AB, dog class is having two variables AC. Next animal class is having two methods eat and sleep, dog class is having two methods eat and bark. But if you see this eat method is there in both the animal class and the dog class, this method is called overridden, this is called overriding, and the variable is also same. Okay, so this variable will hide this variable. Okay, now I will explain the typecasting, means upcasting. Okay. Now without upcasting, first I will write one more class test. Already this is a program on inheritance. After that I will explain this upcasting. Okay. Now here if you see this program, here there is no upcasting concept. It is simply a inheritance program. So here we have two classes now, superclass and subclass. By creating the object for superclass, we can access only members of superclass. If you create object for animal class, we can access only the members of animal class, that is A, B, eat and sleep. But if you create object for subclass, we can access both superclass and subclass members. That is, if you create object for subclass, that is dog class, then with that dog class object I can access both superclass members and subclass members. So here by creating object for subclass, what we can access? Dogs class A, because instance variable hiding concept. So dog class A and animal class B and dog class C and dog class eat and animal class sleep and this dog class bark. So with dog class I can access three variables, that is dog class A and animal class B and dog class C. Three variables A, B, C I can access. Like that, three methods I can access with dog class object. They are dog class eat method, animal class sleep method and dog class bark method. This already you know in inheritance. First I have taken a class test. Inside that I have created only objects for only superclass and only subclass. So this is the object creation for only superclass. Animal A1 is equal to new animal. This is the object creation for only subclass. So with this what we can access, already explained, only animal class members we can access. What are the animal class members? With this A1 I can access animal class A, animal class B and animal class eat method and animal class sleep method. If you execute this program, you can understand only all the animal class members, okay, will be the output. Animal class A, animal class B, animal class eat and animal class sleep. Because A1 is the reference variable for animal class. Next after that, I have created object for only subclass, purely for subclass. Dog D1 is equal to new dog. With this I can access both the members of superclass and subclass, but we have to use the concepts instance variable hiding and method overriding. So with those two concepts, I can access three variables and three methods. But here you have to understand this A is dogs A and this eat is dogs eat method. This concept is because of instance variable hiding and this is because of method overriding. So already explained this concept in case in method overriding. Okay, now already we know. Now that is without upcasting. We have this output. Next, after that, in place of this class test, I will replace this class test with this class. Now it is the new concept. Here I am adding upcasting concept. Now I will take the same class test. Okay, in addition to the superclass and subclass, I am taking one more class test to create the objects for superclass and subclass. And here I am explaining the concept of upcasting. We will see. So class test. See, already in this program also we have two classes. They are animal class, then dog class. After that we will write this class test in the same program. In one program we can write any number of classes in Java. In this program I have three classes, and I am explaining the concept of upcasting in this program. That's why I have taken three classes. They are animal, which is superclass, dog, which is subclass, and one more class test. In that I will write the main method and I will explain the concept of upcasting. Okay. In the previous class test, I have created only purely for superclass and purely for subclass. Here the objects are created for superclass and subclass. But instead of creating objects purely for superclass and subclass, what I will do is, I will create the object for subclass. See, this is the object for subclass. And this subclass object is assigned to superclass reference variable. Means here with respect to two classes, I am explaining upcasting. Understand carefully. In case of primitive data types, with respect to two data types, we are explaining primitive typecasting. But in non-primitive typecasting, with respect to two classes, I am explaining upcasting and downcasting. What are the two classes? Superclass and subclass. If you observe these two objects, here both sides same class. Means it is the object which is purely for animal class. That's why animal. Here if you take this one syntax, this is the only the object for dog class. Animal means animal class object. Dog means dog class object. So both left hand side and the right hand side we are using the same class name in both these objects creation. Okay, that's why this is called superclass object, this is called subclass object. Now what I am doing is, I am using two classes, both superclass and subclass in the same statement. That's why it is called upcasting. What is upcasting? Already explained. Subclass object. Is it subclass object? Already explained. Only right hand side part is called object. That's why this is dog class object. No? That's why this is called subclass object. Subclass object is assigned to what? Superclass reference variable. How do we write superclass reference variable? This left hand side syntax is nothing but superclass reference variable. So you know A2 is called a reference variable which is of animal type, and animal is a class. That's why A2 is called a reference variable. So left hand side is called animal class reference variable and right hand side is called dog class object. So upcasting is nothing but subclass object is assigned to superclass reference variable. So if you write like this, then this is called upcasting. What is upcasting? Subclass object is assigned to superclass reference variable. So this upcasting is like implicit typecasting in case of primitive data types. Means the programmer need not worry about this typecasting. Okay, so internally what the compiler will do for this statement is, it will add this typecasting. Okay, so here always typecasting is done with left hand side type. What is the left hand side type? Animal. That's why internally the compiler will add this to this statement. So now this statement becomes like this. If you want to add this explicitly, we can also add, no problem. Okay, but if you won't add, then the compiler will add. It is like implicit typecasting. Okay, so if you write subclass object is assigned to superclass reference variable, internally the compiler will do the typecasting with superclass. Why it is called upcasting is, if the casting is done with superclass, Here we have taken two classes, animal class and the dog class. Animal class is called superclass, no, we know. That's why here we are doing the casting with which class? Superclass. Superclass is nothing but animal. That's why this casting is nothing but upcasting. Why? Because superclass, the casting is done with the superclass. Okay. And how to do upcasting is by assigning subclass object to superclass reference variable. So this statement is called upcasting. Next, after writing like this, what we have to do with this reference variable A2, what we can access, that is the important point now. So if you see these two statements, so with this A1, we can access only the members of animal class now, because it is purely the object for animal class. So that's why with this reference variable A1, we can access only the members of animal class. Next, if you see this dog class object, with D1, we can access the members of both superclass and subclass. But like that, here in upcasting, with this reference variable, what we can access is, we can access all the members of the superclass. See, all the members of the superclass except overridden methods. Okay, so understand the concept of upcasting. So this is upcasting syntax. With this reference variable, we can access all the members of the superclass except overridden methods. Shall we see animal class? Is there any overridden method in animal class? This is animal class, no? All the members of the animal class. What are the members of the animal class? A, B, then sleep, correct only. Now it will check whether any overridden method is there in animal class. Yes, one overridden method is there, no? Because this eat method is there in both animal class and dog class. Already explained. In overriding, if one method is there in both superclass and subclass, superclass method is called overridden method and subclass method is called overriding method. So with upcasting, what we can access with that reference variable is, we can access all the members of the superclass except overridden method. This is the overridden method we have in animal class. Except this method, all the members of animal class are accessed. But in case of overridden method, what will be executed is, dog class eat method will be executed. This is the concept of upcasting. So except overridden method means, in case of overridden method of the superclass, what will be executed is, dog class eat method will be executed. Now, is this what we can understand? Shall we write? Okay. And now here I will explain. So with that reference variable, we can access all the members of the superclass now. That's why we can access the animals A. You will get 10. The animals B 20. Animals sleep method. That is the animal sleep method. You will get the output. And in case of eat method, that is in case of overridden method of animal class, the subclass overriding method will be executed. Means you will get the dog eat method. You will get. So finally, you will get the output is with upcasting. A is 20. You will get. B, A is 10, you will get, B is 20, and animals sleep method, and in case of this overridden method, we will get the output as dog eat method. This is the concept of upcasting. So you can remember with this, with the reference variable, we can access with this reference variable because it is upcasting statement. This or this, both are correct. Okay, both are correct. So with this reference variable, we can access all the members of the superclass except overridden method. Means here there is only one overridden method in superclass, that is eat method. So in case of that eat method, dogs class eat method will be executed. That's why if you see the output, we can access A, B. So you will get 10 and 20. Both these are animals class variables. 10, 20. You will get the output 10, 20. After that, I will write A2 dot eat method, because eat method is there in animal class. No? What is the statement? We can access all the members of the superclass. Superclass members are A, B, eat and sleep. No? These are the only 4 members in superclass. So I am accessing only those 4 members with this upcasting variable. But A is superclass, B is superclass, but in case of overridden method, subclass overriding method will be executed, that's it. But it will take only superclass members. What are the superclass members we have? A, B, eat and sleep. That's why I have written only the members of superclass only. But here only one class is in case of overridden method. Okay, subclass overriding method will be executed. But if you see A, B, eat and sleep are members of the superclass only. That's why with that reference variable we can access all the members of the superclass. Remember this point, all the members of the superclass. We can access only the members of the superclass except overridden methods. Except overridden methods means here only one method is there in superclass, that is overridden method. In case of that method only, subclass overriding method will be executed. That's why if you understand this output, this is animals A, animals B 1020, and in case of overridden method, the subclass overriding method will be executed, that is dog sleep method. Sleep method is not overridden method, that's why animals sleep method will be executed. So this is a program on upcasting. Next, coming to what is the drawback of this upcasting is, what here with this upcasting we can access all the members of the superclass now. Means superclass A, superclass B, superclass sleep, but in case of overridden this is no. But here what is the drawback of upcasting is, the remaining members of the subclass are not accessed. What are the remaining members of the subclass? This C cannot be accessed with upcasting, and this bark method cannot be accessed with upcasting. Okay, C and bark method of dog class cannot be accessed with upcasting. So that is the drawback of upcasting. To overcome that drawback, we will go for downcasting. So what is downcasting? So drawback of type, we can't access the remaining members of the subclass like A means A is there in both, A, C and bark also. Here write bark method of the dog class cannot be accessed with upcasting. So to access the remaining members of the subclass, we will go for downcasting. Always downcasting must be followed by upcasting. So for downcasting, upcasting is required. Okay, first you need to write the upcasting statement, followed by you need to write one more statement, that is for downcasting. Okay, it cannot be done individually. We can't do downcasting individually. Here I will show you that one. This is also easy. This is the program for downcasting. Okay, first take animal class same members. Next dog class also same members, followed by write this class. If you want to write upcasting, you need to take 3 classes. Like that, if you want to write downcasting program, you need to take 3 classes. They are animal class. On the top of this class, we have to write animal class, dog class, and then next write the test class to write the main method. This is downcasting syntax. Downcasting is first you need to do upcasting only. Is it upcasting? Already explained. Upcasting is nothing but subclass object is assigned to superclass reference variable. So this first statement is called upcasting. Followed by we need to write downcasting. This is called downcasting. The why it is down means we are doing the casting with subclass, that is dog. This is animal. That's why this is called upcasting. Upcasting followed by downcasting we are writing. This statement is called downcasting statement, but these two statements together we should write for downcasting. Why? Because we are casting this variable A3. A3 is what? This upcasting variable is downcasted here. That's why first you write upcasting and take that variable here and do downcasting that variable. So this is downcasted with this one. Means down means subclass. Downcasting means if the casting is done with the subclass, then it is called downcasting. But even though it is downcasting statement, we can't write this statement alone. Why? Because here we are using the variable A3 which is created with upcasting. That's why here two statements together only we have to write. Okay. Now what I will do? Dog D2 is equal to dog A3. This is explicitly we must write. The compiler will not provide this downcasting, that is cast with the dog. But this is done by the compiler. Like implicit typecasting, this is like explicit typecasting. Compulsory the programmer has to do this downcasting. Okay. Now is it the downcasting statement? Yes, because dog D2 is equal to dog A3. This reference variable is downcasted. After that, always I explained the left hand side class will be used for casting. What is the left hand side class? Dog. That's why I used that dog for casting. So these two statements together is called downcasting. Now here you know already this is only upcasting statement. Upcasting only one statement enough. For downcasting two statements are required must. And with this upcasting variable, you know how we can access all the members of the superclass except overridden methods with this A3. But with D2, what we can access is, it is like dog class object. You know, dog D3 is equal to new dog if you create. So that statement is same as this statement. So it treats this as like dog class, purely dog class object. So with the dog class object, what we can access, with this downcasting variable D2, I can access the same thing. So with the dog class object already explained, no? Here I explained without typecasting. This is dog class object, no? This is purely for dog class, no? So this is the dog class object. With D1, what we can access, with the downcasting variable also we can access the same thing. Okay. And now here you may get one doubt. Now why downcasting is required? Directly we can create subclass object. No, because using downcasting variable we are accessing the same thing. No. Okay. So it is similar to subclass object. Here you may get one doubt. No. Instead of this, I can directly create subclass object. No. But so in some applications, so we have, first we need to do upcasting, followed by, to access the remaining members of the subclass, we have to use this downcasting. In some applications are there. We have programs are there like this. First we have to do upcasting. Then afterwards, to access the remaining members of the subclass, we need to do downcasting. That's why in some applications, the downcasting is required. That's why if you, even though it is behaving like a subclass object, but in some applications where we require upcasting followed by downcasting. Okay. Next after that, it is similar to dog class object. No. That's why with the dog class object, what we can access, dog class A and the animal class B and the dog class C and the dog class eat method, animal class sleep method and dog class bark method. So if you see this part, it is similar to the subclass object. Okay. Instead of this, we can write dog D1 is equal to dog. Same thing can be accessed. But this is sometimes required. Okay. In some applications, first we will do upcasting, followed by we must do downcasting to access the remaining members of the subclass. Because using upcasting, we can't access some members of the subclass. To access the remaining members of the subclass, after upcasting, we need to do downcasting. Okay, applications are there with with these two statements. Okay, that's why try to understand this statement is nothing but like the subclass object. Okay, so with this downcasting is completed and upcasting also completed. Next last one is, so in inheritance with respect to superclass and subclass, we will create the objects as follows. So how many ways we can create objects and what are the correct ones and what are the wrong ones we will see here. Okay. Now with this is superclass, you know, this is subclass, you know. So with respect to this superclass and this subclass, there are 6 ways to create objects. There are 6 ways to create objects. We will see. Now first one is purely animal class object. That is superclass object. So it is 100% correct. Okay. Next, no error. Next, this is the subclass object. Dog D1 is equal to new dog. It is also 100% correct. No error. Next, animal A1 is equal to new dog. This is also 100% correct because it is upcasting. Now we have to identify the syntax for upcasting and downcasting in addition to the superclass object and subclass object. Okay. Now here we are taking 2 different classes, animal and dog. Okay. Now here it is subclass. Syntax is subclass object is assigned to superclass reference variable, but this casting is taken care by the compiler. No need to worry about this casting with animal. So it is 100% correct. It is the syntax for upcasting. Okay. Next, what is the fourth way is, I am taking two classes here also. Dog dt is equal to new animal. So how to read this statement is superclass object. You know this is superclass object, no? Superclass object is assigned to subclass reference variable. It is not correct. Our upcasting is subclass object is assigned to superclass reference variable. This is the correct syntax for upcasting. This is the wrong syntax. If you write like this, syntax error, that's why compiler will throw an error saying that it is some error it will give you. This is called compiler error. Syntactically, we can't write like this. Means superclass object cannot be assigned to subclass reference variable. That's why fourth one is wrong. You will get compiler error. Next, fifth one, we will see the syntax. So if you see the first statement, is it upcasting? Yes. So subclass object is assigned to superclass reference variable, followed by this, is it correct downcasting? We will see. Always this reference variable is downcasted. No? Whatever variable here, if you take in upcasting, you should take the same variable and the same variable must be downcasted. Down means dog, no? That's why dog d1 is equal to dog of a1. This we must write explicitly. This casting we must write explicitly. Suppose if you won't write this casting with the dog, you will get again compiler error. Syntactically wrong. Okay, so you must write this casting explicitly. That's why this variable is casted, no, with the subclass, no. That's why it is the syntax for downcasting. And so this is correct. Next, last one is sixth. So here instead of using upcasting, that is subclass object is assigned to superclass reference variable. Here what I am doing is I am creating only superclass object, and with that reference I am taking that reference variable for downcasting. Is it right as per downcasting syntax? No. Always for downcasting we must do upcasting. Then using that variable only we will do downcasting. Okay, same variable we have to use. But here, see, if you see the syntax, it is not the syntax of upcasting. Here we are purely creating the reference variable for superclass, and I am trying to downcast that variable. So it is not correct. It is not the correct syntax. So you have to identify the correct syntaxes. Then only you can write the programs perfectly. Otherwise, you may get compiler errors or runtime errors. So this is not compiler error. This is runtime error. And in exceptions, exception is nothing but runtime error. And what is the type of this exception is class cast exception. Means this casting is not done properly. Actually, you have to do like this. This reference variable is casted. But here I am doing the wrong casting. That's why this type of exception is called class cast exception. So exception handling is there in the third unit. There we will study in depth about the type of the different types of exceptions. This is one type of exception where we do the wrong casting like this. This casting is nothing but class cast exception. Single word all. Okay, in exception handling I will explain in depth. This is called runtime error. This is called compile time error. So out of 6 ways to create objects using superclass and subclass, only 4 ways are correct. They are only we can create only superclass object, or we can create only subclass object, or we can do only upcasting, or we can do downcasting like this only. Downcasting must be followed by upcasting. That's why first you need to do correct upcasting followed by correct downcasting. Downcasting must be do explicitly. Okay, upcasting we need not worry about upcasting. Compiler will take care. So this is the correct downcasting. Okay, here this if you do like this, it is a compiler error. If you do like this, it is runtime error. Okay. So with this typecasting in Java is completed. So in Java, typecasting is very, very important. That too, this non-primitive typecasting is very, very important. That is upcasting and downcasting.